All right, welcome to Making Connections Between Arithmetic Sequences and Linear Functions, Day 2. So starting off with our vocabulary. Our vocabulary word is first difference, and first difference is the value determined by subtracting consecutive output values. Okay, and then a note that I want you to make is that, I'll put it over here, if first differences are constant, the relationship is linear. All right, and we will have examples for this vocabulary word because I know looking at it, you probably don't understand it yet, but that's okay. I will go back and explain it as we do our example. Also, on the right side, we have the slope formula. Just going to highlight it here. Slope formula, it's not a definition, but it is also something we need to remember for today's lesson. And so here we have m, which stands for the slope. M is equal to y2 minus y1 over x2 minus x1. And this is for a pair of points when you have the 2 points x1, comma, y1. And then you have another point x2, comma, y2. There we go. So for 2 points, you would plug in the x's and the y's into the slope formula like this. So you're probably wondering, I have no clue what this means, so I'm going to give you an example by zooming in over here. So let's say you have 2 points like this, 3, 4, and 6, 7. Okay, if these are your 2 points, and we wanted to find the slope between these two, then you would plug them into this formula. So let me show you that our x1 would be 3, our y1 would be 4, our x2 would be 6, and our y2 would be 7. So when you're plugging it into the formula, we have y2, it's 7 minus y1, which is 4, divided by x2, which is 6, minus x1, which is 3. So I'm going to highlight everything so that you know what happened. So our y2 is 7, those are the blue numbers, minus the y1, that's yellow, so these are the yellow numbers, divided by the x2, those are the purple numbers, minus the x1, those are the green numbers. Okay? Now some of you might be wondering, what if I had the points given to me in the other order? So here I said 3, 4, and 6, 7. What if the points were 6, 7, and 3, 4? Does the order of the ordered pairs matter? No, it doesn't. So if you were to plug this in the other way, it would have been 4 minus 7 over 3 minus 6. That is totally fine as well, because if you were to simplify it, this one becomes 3 over 3, which is 1. And the second one, the switched order, becomes negative 3 over negative 3, which is still 1. So either way, you get the same answer. So it doesn't matter which point you put first, okay? It does not matter which point you put first. All you have to do is subtract the y's on top and subtract the x's on the bottom, okay? So this is the slope formula and one example. And so going back to the problems that we are given, we're going to use each scenario to complete the table of values and calculate the rate of change. So in our first example, it says Maria is working on her math assignment after school. She completes 3 problems every minute. Now this might sound familiar to you because we did see this problem 2 days ago. So 2 days ago we did this exact problem, except in a different form. So we have to label the quantity for independent quantity and dependent quantity. So 2 days ago, we discussed that the independent quantity was time and the units were minutes. And then for the dependent quantity, I don't want you to worry too much about it. It's problems. That's not how you spell problems. There you go. And the units, you can just put problems again, because I don't know how you would describe number of problems other than just problems. So time in minutes and problems in problems. It's okay. And for the expression, this time we're just going to use x for the independent quantity. And then for the dependent quantity, we're going to put 3x because she completes 3 problems every minute. So the number of problems she completes is 3 multiplied to the number of minutes. Okay? So it's 3 multiplied to x. And now we're going to fill in our t-table. So to fill in our t-table, you're just going to plug in the x value given. So our first x value given is 5. So it's 3 times 5, and it gives us 15. Then we plug in our next one. Our next x value is 10, so plug in 10. 3 times 10, what are we plugging it into? We're plugging it into our expression right here. So 3 times x, so 3 times 10, which gives us 30. Next, plug in 15. 3 times 15, and you get 45. And then next, we have 20. So 3 times 20, and then this gives us 60. And then finally, we have 25. So 3 times 25, and this gives us 75. So now we filled in our t-table. So if you have any questions up until this point, you should call me over so that you can ask me for help. I don't want you to just sit there and be confused, okay? That is never the goal. The only reason I record lessons ahead of time is because I know that Zoom lags when I teach live. So that's why I record the lessons ahead of time so you don't have to lag with me, all right? So if you have any questions, please let me know. Other than that, we're going to calculate our rate of change. So to calculate our rate of change, we want it to be consecutive x values. And so our x values are not exactly consecutive. They have 5, and then it goes to 10. When we should be going from 5 to 6, that would be consecutive. But 5 to 10, we are skipping some numbers, right? From 5 to 10, you have to jump 5 times. And then on the right side, let's take a look at how much we are jumping here. From 15 to 30, what is 30 minus 15? How much are we jumping? We are jumping 15. Let's see if this pattern holds up. So if we continue, we are jumping 15 on the right side, and we are jumping 5 on the left side. So the pattern is continuing. That's good. So we're going to use these numbers to calculate our rate of change. So to calculate our rate of change, the first difference, which is the rate of change, it's the value determined by subtracting consecutive output values. So we're going to calculate this by taking this number. I'll just highlight it. 15 divided by, let's use this color, 5. So if you divide 15 divided by 5, you'll get our rate of change, which is 3. Okay, so our rate of change is 3. And I also want you to notice that this rate of change, this 3, you can see it in our equation right over here. It's the number that's being multiplied to x every single time. Let's do the same thing for the problem on the right, so for number 2. So for number 2, it says, the math club sells protractors as a fundraiser. Each protractor costs $2. Okay, so this problem also should seem familiar because we did it in class 2 days ago. And so the quantity for this one of our independent quantity for this one is protractor. And protractors are just measured in the units of a protractor. So don't worry, you can write the word protractor twice. I'm not too focused on the language here, it's okay. And the dependent quantity is money. And the units we use for this is dollars because we are currently in America, or at least I think you are. I wouldn't know because we're an online school. So money measured in dollars. And then for the expression, just use x, please, for your independent quantity. And for your dependent quantity, write the expression 2x. So it's 2 multiplied to x, and that's because the amount of money the math club will raise is $2 multiplied to the number of protractors. So 2 multiplied to x, where x represents our protractors. Okay, so now that we've done that, let's plug everything in to fill in our t-table. First number we are plugging in is 2. So we're going to say 2 times 2. And this gives us 4. Next, we are plugging in the number 4. 2 times 4. And that gives us 8. Next, we are plugging in the number 6. 2 times 6 gives us 12. Next, plug in 8. 2 times 8 gives us 16. Next, plug in 10. 2 times 10 gives us 20. So now we've filled in our t-table. Okay, so then let's calculate our rate of change. So let's see how much does every number jump on the left side. It jumps by 2. To go from 2 to 4, you have to add 2. To go from 4 to 6, you have to add 2. So every single time on our left side, we are jumping by 2. Now, how much are we jumping on the right side? So on the right side, from 4 to 8, we are jumping 4. 8 to 12, you are jumping 4. 12 to 16, also jumping 4. 16 to 20, we are also jumping 4. So we're going to do the same process to calculate our rate of change. Take this 4, put it on top. Divide it by the left side jumping amount, 2. So we take 4 divided by 2, and then we get our answer, our rate of change, which is 2. All right, and so I did point out on the left side, on number 1, over here, that the rate of change can be visible in our problem over here. So the same thing can be seen on number 2. So our rate of change that I just highlighted can be seen in our example in the t-table and our expression over there, multiplied to the x. So the rate of change is actually multiplied to the x every single time. Okay, so that's it for number 1 and 2. Let's scroll down a little bit. Oh, remember, if you guys have any questions, you need to let me know so that I can help you out. Okay, so now where it says using the first differences to calculate the rate of change, and it says a note. The note is that you want to divide the green numbers. I don't know how else to call it. Let's just call it the green numbers. By the yellow numbers. To get the rate of change. You can abbreviate rate of change as ROC. ROC stands for rate of change, okay? So to calculate the rate of change, you divide the green numbers by the yellow numbers. That's what we did, and so that's the key that I'm writing over here. All right, let's scroll down to continue. We are going to do the same process over here for number 3 and 4. So for number 3 and 4, we actually gave you guys a space to show how much you're adding every single time. So let's take a look. In number 3, how much are we jumping from 7 to 12? If you guys don't automatically know, you can subtract it. 12 minus 7, and you can get the number 5. So this is our first difference. So you just subtract these numbers. In the second box, let's subtract the next two numbers. We got 12 going to 17, so it's 17 minus 12. You subtract them and you get 5. The next number jump is 17 to 22, so you're going to do 22 minus 17, and you get 5. The next jump is 22 to 27, so you subtract them, and you get 5. Notice that all of these say 5. They are all the same. So this is our first difference. I'm just going to write that out here. And since all of our first differences are the same number, that means we have a constant first difference, then this shows that we have a linear equation or a linear situation. That was part of our definition. I'm going to scroll up a little bit. In our definition, we stated that if the first differences are constant, the relationship is linear. So over here, our first differences are 5. It's constantly a 5. So that means we do have a linear situation. That means they form a straight line if you were to graph it. Anyways, so now we're going to use the rate of change or calculate the rate of change. Let's double check to see if, to calculate our rate of change. Sorry, my brain blanked for a second. So these numbers, these are our green numbers. They come from the right side. And then now we need to take a look at our left side. How much are we jumping over here? So from 0 to 1, 1 to 2, 2 to 3, 3 to 4, we're only jumping 1. So that's a good thing. Let's calculate it. So you're going to take the green number on top. Oops. Green number on top, which is 5. Divide it by the yellow number on the bottom, which is 1. So 5 divided by 1 is 5. Our rate of change is 5. Let's do the same process on number 4. So let's calculate our first difference. So let's see, how much are we jumping from 33 to 29? We have 29 minus 33. We get negative 4. Calculate again from 29 to 25. We subtract 25 minus 29, and then we get negative 4. Jumping again, we get 21 minus 25, and we get negative 4. Why is it negative? If you're wondering why it's negative, it's because our numbers are decreasing as we go down our t-table. They are decreasing. So that's why we have a negative first difference. Okay, let's take a look again. For this one, we're jumping from 21 to 17. So 17 minus 21, you subtract it, you get negative 4. Okay, so now let's take a look to see on the left side if we are jumping by 1. Oops. So from here to here, we are jumping by 1. 5 to 6, still jumping by 1. 6 to 7, still jumping by 1. So we're all good here. Let's calculate our rate of change. We have the numbers on the right, negative 4, divided by the jump number on the left, 1. So negative 4 divided by 1 is negative 4. Our rate of change is negative 4. All right, so if you have any questions, please make sure to let me know. But that is it for this video. So to calculate the rate of change, I'm going to change the note over here. Since you guys might not have colors, I'm not going to call this the green number. I'm going to call it the right side, or the output difference. The green numbers are the output difference. So the output difference is subtracting your dependent quantities, okay? So those are all the green numbers that we did. And the yellow numbers, we can call that the input difference. Okay, so the yellow numbers would be subtracting your independent quantities to get this yellow stuff over here. And then the output difference would be the numbers you get when you subtract your dependent quantities. Okay, so if you have any questions, you can always replay the video or call me over for help.